Goodness. Okay, so we are going to, so the last two videos were a scientific notation video, and it was transferring. It was converting from standard to scientific. And then the one literally right before this one was converting from scientific to standard. Now what we're going to do is we're actually going to look at numbers that are being multiplied together in scientific notation. After we solve that one, it'll have us write it in standard notation. So we'll do the conversion at the end, and then we're actually going to divide two numbers that are in scientific notation. After we get that quotient, it'll have us convert to standard notation. Okay, that's a whole bunch of words. So let's just do the work. Okay, let's math. Okay, so we're going to multiply and divide. Scientific notation. Okay, that's not pretty. And that's a little bit better. Okay, so let's do this example. Say what we're given in parentheses is 3, that's times 10 to the 7th, close your parentheses. And then let's do open parentheses, 3 times 10 to the 4th. Okay, so what you do is you actually are going to do math on the just the plain numerical values 3. And when you multiply them together, you're then going to look at your base 10, right? Your 10 to the something power. Our 3 times 3 is 9. Signs are the same, so it's a positive 9. Then we have our multiplication symbol. And then now we have 10 to the 7th times 10 to the 4th. We had done a video over exponents, which had said that our exponents are attached to a base. So here, that's why I said it's a base 10. Scientific notation is using base 10. Because those are the same bases, I can use the exponent rule, which is the product rule. And that rule states that what you do is you keep your base and you add your powers, 7, 8, 9, 10, 11. So that would be the product of that multiplication. Then it tells me to convert into standard form. Well, I learned in the previous video that if my exponent is positive, my decimal moves to the right. Do you agree with me? That's where my decimal is, right? Because there isn't one that I see, so that means it's right after our 9. So if I move the decimal to the right, I'm going to move it 11 times to the right. So I have my 9. When you move your decimal to the right, don't you fill all of that in with zeros, right? So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is your number. I'm not even sure. Let's see. 3, 3, 3, 1,000, million, billion. It's what I wish, I made yearly being a math professor. Just being honest, y'all. Okay, so that's multiplying the way we would write it in scientific notation after doing the multiplication, and then using that product to actually convert it into our standard notation. Now, let's do a division problem. Say in our numerator, we get x times 10 to the negative 7 divided by 2x, that's times, right? 10 to the negative 3. Okay. Well, if I look at my 8 and my 2, I know that 8 can be equally divided by 2, right? 2 would go into 8 4 times. So I have my 4. And then when you look at our base 10s, those are the same base. Because I'm dividing, I would use that exponent rule, which is the quotient rule. And the quotient rule says if you have the same bases dividing each other, you keep your base and you subtract your powers. Y'all, that's what we did here, but it was multiplication. So we kept our base and we added. the powers. With division, you keep the base and you subtract your powers. Well, that's a whole lot of stuff going on in my powers. So let me go and write 4 times 10. And then let's look. Do you agree with me, y'all? That kind of looks like a broken smiley face, like, I don't know, the negative, parenthesis negative. It looks like a smiley face to me, like the eyes and the nose. And I'm like, oh, when you're smiling, you're positive. Make it a big plus sign. You could say it looks like a broken plus sign. Make it a big plus sign. You can think of it as negative times a negative. That makes a positive. Whatever you need to do to know that if you have those two negatives touching each other, the only thing that's in between them, it's not a number, it's just a parenthesis. Then what that does is it actually becomes positive. So now look at my exponent. I have negative 7 plus 3. Well, done this before, right? Signs are different, so we subtract, keep the sign of the larger value. I get 4 times, that's a base 10 to the negative 4th power. Well, I learned that if my exponent is negative, my decimal moves to the left. Where's my decimal, y'all? Right there. Now let me go ahead and write this. Because I'm moving to the left and I know I'm going to fill in zeros, when you go to write your answer, I wouldn't write a 4 right here next to my equal sign, right? I'm going to kind of bring it here. And I know that if I move to the left, I feel, I'm not doing it, I'm just saying, right, in general. When I move to the left, I'm going to fill that in with zeros. So what I'm going to do is, here's my decimal next to my 4. I move it over 1 time, 2, 3, 4. Wouldn't I add my zeros like that? That's where my decimal moved. So just to make that look a little bit better, we got decimal 1, 2, 3 zeros, and a 4. So that is multiplying with terms that are in scientific notation, and then using that scientific notation to convert to a standard notation. And then we looked at a problem where we divided terms that were in scientific notation. We applied that division, used a quotient rule. We ended up getting our quotient to that division problem. And then what we did is we went ahead and converted it into standard notation. So that's actually it for that section, y'all. The next few videos that I do record will be on polynomials, which I think actually gets really fun. We're going to add them, subtract them, multiply them, divide them. It's going to be quite awesome. So if you have any questions, make sure y'all ask, okay? Thank y'all. Bye.